Hello, well, have I got a video for you? This video is about the triangle inequality. You're going to use the triangle inequality to decide which side of a triangle is longest and which angle is largest. Now you could also find which side is shortest and which angle is smallest. That's how the triangle inequality works. Kind of a weird name for something, but make sure you get this down, what the triangle inequality is. All right, let's get started. Let's look at example 1. So, if I'm going to erase all these marks, what we have here is, first of all, we have the theorem. What is the triangle inequality? Well, part of it is listed in theorem 511 right there. It states that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. What the heck are we trying to say there? Well, let me show you. What we're trying to say is that if I've got a big angle, then the side not touching the big angle B in this case, is going to be the longest side. And if I've got a teeny angle, the side not touching the teeny angle is going to be the smallest side. So here, side A was, well, here, let me avoid using a variable over there, but you can see this is the smallest side because it's not touching the smallest angle. And here, this is the largest side because it's not touching the largest angle. So always true, the ranking of the angles in terms of how large they are will match the ranking of the sides in terms of how long they are. So what does that mean, for example? Well, in example 1 here, if we were to actually, we can rank them from least to greatest, both the angles and the sides. Like over in A, it's easy to, okay, least to greatest, the angles. Well, obviously, G is the least, then H, and then J is the biggest angle. But now we can say, okay, even without knowing what the sides are, I know that the smallest side is HJ. And the most medium side is opposite H, so JG. And then the longest side is opposite J, so that's GH. And of course, the order doesn't matter of, like, you can switch the order of the two endpoints. Like, instead of saying HJ, you might have said JH. Instead of saying JG, you might have said GJ. And instead of saying GH, you might have said HG. Similarly, if you know the sides, then you can rank the angles. So here, we know the sides, least to greatest, are QP is the shortest, then RP, and then finally RQ. But now we know also, without knowing the measurements, the smallest angle therefore must be angle R. The medium angle has to be angle Q, and the biggest angle has to be angle P. Now, one thing you might notice when you're looking at this is that you can identify the opposite by just noticing the letter that doesn't get mentioned in the side. See how R is not part of QP. So QP, it's the one that uses the two letters. So this way, you can actually come up with some answers without even looking at the triangle. And I made an example like that here. If you have triangle ABC, and if you know that angle A is the biggest angle, then without even looking at the triangle, you know that BC is the biggest side because it's opposite angle A because it has the two letters that don't touch A. So if angle A is the biggest angle, then BC is the longest side. Similarly, if angle C is the smallest angle, then AB is the shortest side. So it works like that. Now, this relationship between angles and the sides opposite them, it doesn't just hold like in terms of ranking them in terms of size. It also helps with isosceles triangles. So in an isosceles triangle, you'll have this this situation where you know two sides are equal. Well, the surprise then, it turns out to be that if the two sides are equal, as they are in an isosceles triangle, then the two angles opposite those sides are equal as well. Now, for whatever reason, we call those base angles. They're the ones opposite the two equal sides. I'll draw the arrow to show the opposite, but I think it just makes it messy, so I'll get rid of that. But what that so that can help you. Like, if, for example, if you know the top angle is 40 degrees and it's an isosceles triangle, well, that means you know these two angles are equal. So then you just say, okay, well, whatever that angle is, I'll call it x. Two of them equals, what does it make? 180 minus 40, or 140. And that means they're both 70 degrees, right? X is 70. So in an isosceles triangle, the opposite, and then what do we know about this? So these are both 70. Sorry, I just stuttered a lot. But the next question is, do we know the longest side or the shortest side? And well, we know that these two are bigger than this. So the 40, opposite the 40, this would be the shortest side, right? And these sides are equal to each other, and they're longer than that not equal side. Okay, that helps us with the problem like example 2. Example 2 shows us a director's chair, and it says, hey, look, we're going to give you that in this chair, there's ABC, you can barely see it, but AB is congruent to AC. I've circled that on the problem, so that AB is congruent to AC, and BC is bigger than AB. What can you conclude about the angles? Well, okay, I know from what I was just telling you that angle B is congruent to angle C, so I've written that here, and they wrote it here because AB is congruent to AC. ABC is isosceles, so angle B is congruent to angle C, which means the measure of angle B equals the measure of angle C. Kind of repetitive. But because BC is bigger, this one is bigger, if it's bigger, if that side is bigger, then guess what? The angle opposite that side is bigger. So that means angle A is greater than, I should write, the measure of angle A is greater than the measure of angle B. And of course, a measure of angle A is also greater than the measure of angle C. All right? So, okay. That covers the first part of triangle inequalities. There's one more thing I need to show you. Impossible triangles. All right. So, if I've got, let's say I've got two buildings. One's 100 feet tall, one's 150 feet tall. And I'm decide to have an explosion that makes the two buildings fall down. And as they fall, well, you could use a compass to imagine their fall through the air. But let's say they fell simultaneously, they would hit each other right there, right? They would hit each other right there. And that place where they hit each other would then, let's say they might hold each other up. This building would be like this. This building would fall into this thing. We'd have a triangle, right? 200 on the bottom, 100 right here on the yellow, and 150 on the red. And that's a triangle. Make sense? Okay, good. Now, this time, imagine two different buildings. One's 50 feet tall, and one's 40 feet tall. Well, as they fell towards each other, I should use the same color. As they fell towards each other, what would happen? Well, the 50-foot one would make it 50 yards across, and the 40-foot one would fall 40 yards across, but they wouldn't hit each other, right? Why not? Because 50 plus 40 is less than 100. And for that very reason, there's no way I can make a triangle that has one side that's 50, one side that's 40, and one side that's 100. Because if you think about it, if there's this one side that's 100, the side that's 50 could never reach the side that's 40 over here. They can't, because they can't reach across 100. 50 plus 40 is less than 100. And that's the triangle inequality right there. With sides A, B, and C, triangle with sides A, B, and C, A plus B must be greater than C. I mean, you know that for a right triangle, A squared plus B squared equals C squared, but even in those cases, A plus B is greater than C. For example, you got your 3, 4, 5 right triangles, your favorite one. 3 squared plus 4 squared equals 5 squared, but you notice 3 plus 4 is greater than 5. And it works for all sides. 4 plus 5 is greater than 3. And 5 plus 3 is greater than 4. A plus B is greater than C. Always. Doesn't matter which side you pick. You cannot have one triangle that is bigger than the other two. So, for example, 4, 2, and 5. Is this a possible triangle with those three sides? Well, 4 plus 2 is greater than 5, so that works. 2 plus 5 is greater than 4, that works. And 5 plus 4 is greater than 2. So this one is possible, yep. But 2, 2, 5 is not possible because 2 plus 2 is less than 5. So this is not a possible triangle. What about 2, 3, 5? Well, is 2 plus 3 greater than 5? No, it's equal. That's also not possible. Think about it. If 5 is your base, and you've got 2 going this way, and 3 coming back this way, there would be the triangle would have no height because the 2 and the 3 would just touch each other. If they were both buildings standing here, and they would fall down before they touched each other. And so you wouldn't have a triangle, you'd have a line. So again, A plus B has to be greater than C. That's the triangle inequality rule. Thanks for watching. I'm out.